Hi there, Joshua here. Right, let's see what we've got down here. We've got a whiteboard pen, we've got a ruler, we've got a pink microphone, obviously. We've got a drawing pen, and also got a green shirt. Nothing to do with the lesson, I'm just clearing my living room. I've got a video to make, haven't I? Let's get on with the lesson. Right, so welcome to this lesson on measurements, upper and lower bounds. This lesson is going to be in two parts. The first part is going to be me talking about what bounds are and how to work them out, and that should last about 10 minutes. And then in the second part of the lesson I'm going to be doing 3 questions on upper and lower bounds. So let's start with me talking about what bounds are. So suppose I told you that I've measured this pen and that it's 12 centimetres to the nearest centimetre. So it's 12 centimetres to the nearest centimetre. So that's not an exact measurement, that's a rounded measurement. There's lots of different possible lengths that the pen could be. So if you imagine a number line or a ruler, I'll put 12 here, 13 here, 11 here. So the length rounds to 12, so it could be 12.2, for example. That's a length that rounds to 12, 12.2. Or it could be 11.6, that's a length that rounds to 12. Or it could be 11.84, that's another length that rounds to 12. So there are lots of possible values for the length of the pen. And what I want to know is, what is that range? From smallest to largest, what could the length of the pen be? Well, if it rounds to 12, to the nearest centimetre, then it's got to be between here and here. It's got to be somewhere in this range. I'm just marking the halfway point between the whole numbers. So it's got to be between 11.5 and 12.5 if it rounds to 12. So we say 11.5 is the lower bound, or the lower boundary. So the lower bound is 11.5, and 12.5 is the upper boundary, or the upper bound. So that's 12.5. And if the length rounds to 12, it's got to be somewhere in between. It's got to be somewhere in that range. Now you might be thinking, is it okay to put 12.5 here? Because doesn't 12.5 round up to 13? And it's true, usually numbers that are in the middle, usually we do round them up. Sometimes we'll round them down, it's kind of a choice, but usually we round them up. But when I write this, all I'm saying is that the length of the pen is somewhere in between these two numbers. So these are the boundaries and the length is in between. So 12.5 is the boundary between numbers that round to 12 and numbers that round to 13, just as 11.5 is the boundary between numbers that round to 12 and numbers that round to 11. So they're just the boundaries and the length is somewhere in between. It's also worth mentioning that if we are assuming that 0.5 numbers round up, then there is no other number I could put here really, because there's no biggest number that rounds to 12. You might think, what about 12.49? Isn't that the biggest number that rounds to 12? But I could come along and just stick a 1 on the end, and that would be a slightly bigger number that rounds to 12. And you might think, okay, what about 12.4999 with a whole bunch of 9s at the end? But however many 9s you put at the end, I could always come along and just stick a 1 on the end of that, or some digits on the end of that, and that would be a slightly bigger number that rounds to 12. So there is no biggest number that rounds to 12, so I've got to really use 12.5 here. That's the boundary between numbers that round to 12 and numbers that round to 13. Right, let's do another example. Suppose I measure the length of this whiteboard, and suppose that I find out that it's 1 metre to the nearest metre. So 1 metre to the nearest metre. What's the range of possible lengths for the whiteboard? So what's the lower bound and what's the upper bound? Again, I'll do it on a number line. So it rounds to 1 to the nearest metre. That just means that 1 is the whole number it's closest to. So I'll just mark the whole numbers either side, 0 on this side, 2 on this side. If it rounds to 1, to the nearest whole number, that means it must be in this range. So what's the lower bound? It's 0.5 and the upper bound is 1.5. So 0.5 to 1.5, they're the bounds, and the length of the whiteboard is somewhere in that range. Right, going back to the pen. Suppose I told you I've measured it more accurately, and it's 11.7 centimetres to 1 decimal place. 11.7 centimetres to 1 decimal place. What's the range now? So what's the lower bound and what's the upper bound for this measurement? What do you think? Well, it rounds to 11.7 to 1 decimal place, which means 11.7 is the 1 decimal place number that it's closest to. So I'll just mark the 1 decimal place numbers either side, 11.6, 11.8. So if it rounds to 11.7 to 1 decimal place, it must be in this range. So the lower bound is 11.65 and the upper bound is 11.75. 11.65 to 11.75. And the length of the pen is somewhere in that range. Going back to the whiteboard, suppose I've measured that a bit more accurately, and it turns out that it's 1.2 metres to 1 decimal place. What's the range now? What do you think the lower bound is, and what do you think the upper bound is for this measurement? Well, it rounds to 1.2 to 1 decimal place, so that just means that 1.2 is the 1 decimal place number that the length is closest to. So I'll just mark the 1 decimal place numbers either side, 1.1, 1.3. If it rounds to 1.2 to 1 decimal place, that just means it's in this range. So what's the lower bound? Well, it's 1.15 and the upper bound is 1.25. 1.15 to 1.25 metres, and the length is somewhere in that range. Right, suppose I was really annoying and I told you that I've measured this pen to even more accuracy, and it's actually 11.72 to 2 decimal places. 11.72 to 2 decimal places. What's the range of possible lengths now? So what's the lower bound and what's the upper bound for this measurement? It rounds to 11.72 to 2 decimal places. So 11.72 is the 2 decimal place number that the length is closest to. So I'll just mark the pair of 2 decimal place numbers either side, 11.71, 11.73. Since it rounds to 11.72, it must be in this range. So what's the lower bound? It's 11.715, and the upper bound is 11.725. 11.715 to 11.725 centimetres. Those are the bounds. Going back to the whiteboard, suppose I've measured that to 2 decimal places, and it turns out that it's 1.20 metres to 2 decimal places. What are the bounds now? You've got to be a bit careful when it ends in a 0, so just watch out for that. So 1.20 is there. That's what it rounds to 2 decimal places, which means that 1.20 is the 2 decimal place number it's closest to. Just marking the pair of 2 decimal place numbers either side, 1.19, 1.21. Since it rounds to 1.20, must be in this range. So the lower bound, what's that? Well, it's 1.195, and the upper bound is 1.205. 1.195 to 1.205 metres. So a very common error here is to think that the upper bound is 1.25, but it's actually 1.205. So you've just got to be a bit careful if it ends in a 0. Right, going back to the pen, so suppose I've measured it under a microscope, and it turns out that to 4 decimal places it's 11.7204 centimetres. To 4 decimal places. So what are the bounds now? Well, I'll still do it on a number line. 11.7204 is what it rounds to 4 decimal places. So I'll just mark the 4 decimal place numbers either side. 11.7203, 11.7205. So if it rounds to 11.7204, it must be in this range. So the lower bound is 11.72035 and the upper bound is 11.72045. So let's just write that down. 11.72035 to 11.72045 centimetres. Those are the bounds. Right, now you can also do upper and lower bounds for whole numbers as well. So I'm just going to rub off 3 rows and do a few examples of that. Right, so suppose I'd measured a fence, and it turns out that it's 60 metres to the nearest 10 metres. So it's 60 metres to the nearest 10 metres. So what's the range of possible lengths for the fence? What's the lower bound and what's the upper bound? Well, it rounds to 60 to the nearest 10, so that's the tens number that the length is closest to. So I'll just mark the tens numbers either side, 50, 70. So if it rounds to 60 to the nearest 10, it must be in this range. So what's the lower bound? 55, and the upper bound is 65. So the length of the fence is somewhere between 55 and 65 metres. Those are the bounds. Suppose there was a field, and the length of the field was 1,300 metres to the nearest 100. So 1,300 metres to the nearest 100. So what are the bounds for the length of the field, do you think? So 1,300 is what it rounds to the nearest 100. So that's the hundreds number it's closest to. So I'll just mark the hundreds numbers either side. 1,200, 1,400. Since it rounds to 1,300, it's got to be in this range. So what's the lower bound? 1,250, and the upper bound is 1,350. Just write that down. 1,250 to 1,350 metres. So those are the bounds for the length of the field. Right, final example for this bit. Suppose there was a forest, and it was 32,000 metres long to the nearest 1,000. The nearest 1,000 metres. What are the bounds for the length of the forest, do you think? So it rounds to 32,000, that's the thousands number it's closest to. So I'll just mark the thousands numbers either side, 31,000, 33,000. If it rounds to 32,000, the nearest 1,000, it must be in this range. So what's the lower bound? It's 31,500, and the upper bound is 32,500. 31,500 to 32,500 metres. Those are the bounds. So that's the end of part 1. Right, so now I'm going to do a few different styles of questions on upper and lower bounds. I think I'm going to do 4 questions on upper and lower bounds. So there's a rectangle that's been drawn, and imagine that the sides have been measured, and this side is 6.4 centimetres to 1 decimal place, and this side is 3.0 centimetres also to 1 decimal place. And the question says find the lower bound and the upper bound of the perimeter of the rectangle. Remember, the perimeter is just the distance around the outside. So it's asking us to find the range of possible values of the perimeter, given that these are rounded values, and they're not exact. So before we can find the lower bound and the upper bound of the perimeter, we need to find the lower bound and the upper bound of the length and the width of the rectangle. So let's call this side the length, and let's call this side the width. It doesn't really matter which way round. So let's start with the length. So it's 6.4 centimetres to 1 decimal place. So what do you think the lower bound is, and what do you think the upper bound is? While you're thinking about that, we'll just do it on a number line. So it rounds to 6.4 to 1 decimal place, which means it's closer to 6.4 than to any other 1 decimal place number. So we'll just mark the 1 decimal place numbers either side, 6.5, 6.3. And since it rounds to 6.4, it must be in this range. So you can see that the lower bound is 6.35 and the upper bound is 6.45. 6.35 to 6.45 centimetres is the range for the length. What about the width? Let's do that now. So it's 3.0 centimetres to 1 decimal place. So what do you think the upper bound is, and what do you think the lower bound is? You've got to be a bit careful when it ends with a 0 like that. I'll do it in the same way. 3.0 is what it rounds to, so it's closer to 3.0 than to any other 1 decimal place number. So I'll just mark the 1 decimal place numbers either side, 3.1 on this side and 2.9 on that side, so you've got to be a bit careful. Since it rounds to 3.0, this is the range. So the lower bound is 2.95 and the upper bound is 3.05. Let's write that down, 2.95 to 3.05. So as I said, you've got to be a bit careful when it ends with a 0. The upper bound is not 3.5, which is a very common error. The upper bound here is 3.05. Right, now we're ready to find the bounds for the perimeter. Let's start with the lower bound, which I'll write as perimeter lower bound, like that. So basically, to find the smallest possible perimeter, you just use the smallest possible length and the smallest possible width. So you just do 6.35 plus 2.95 plus 6.35 plus 2.95, just going around the shape. So 6.35 plus 2.95 plus 6.35 plus 2.95, and if you add it all up, you get 18.6. So 18.6 centimetres is the lower bound for the perimeter. And to find the upper bound for the perimeter, you just use the upper bounds for the length and the width. So you just do 6.45 plus 3.05 plus 6.45, going around the shape, plus 3.05. And the answer is 19. I'll write it as 19.0. So the lower bound for the perimeter is 18.6, the upper bound is 19.0. So the perimeter of this rectangle is somewhere in between 18.6 and 19.0. Right, so here's another question on upper and lower bounds. I'm going to do 3 questions overall, so this is the second one. So I'll just read it out. It says, Bob runs 100.0 metres in 14.27 seconds. The distance has been rounded to 1 decimal place and the time has been rounded to 2 decimal places. And the question is, find the lower bound and the upper bound of his average speed. And if you remember, to work out average speed, you just do distance divided by time. So in order to find the bounds for the average speed, we first of all need to find the bounds for the distance and the bounds for the time as well. So let's do the distance first. So the distance is 100.0 metres to 1 decimal place. So what do you think is the upper bound and what do you think is the lower bound? So while you're thinking about that, I'll just do it on a number line. 100.0 is what it rounds to, which means it's closer to 100.0 than any other 1 decimal place number. So I'll just mark the 1 decimal place numbers either side, 100.1, and on this side it's 99.9. So you've got to be a bit careful with that. So the bounds are here and here. That's the range, which means the distance is between 99.95 is the lower bound and 100.05 is the upper bound. So 99.95 to 100.05 metres. So that's the range for the distance. Let's do the same for the time. So it's 14.27 seconds to 2 decimal places. So what do you think the lower bound is and what do you think the upper bound is for the time? Again, I'm going to do it on a number line while you're thinking about that. It rounds to 14.27, which means it's closer to 14.27 than any other 2 decimal place number. I'll just mark the pair of 2 decimal place numbers either side. You've got 14.28 on this side and 14.26 on this side. Since it rounds to 14.27, it must be in this range. So the lower bound is here, 14.265, and the upper bound is 14.275. So I'll just write that down. 14.265 to 14.275 seconds. So those are the bounds for the time. Right, now we're ready to answer the question. So to work out the lower bound for the speed, which I'll call S lower bound, speed lower bound, using this formula, so to work out the lower bound for the speed, you don't actually use the lower bound for the distance and the time, surprisingly. You use the lower bound for the distance, but the upper bound for the time. So use 99.95, the shortest distance, but the biggest time, or the longest time, 14.275. If you want the average speed to be as small as possible, or as slow as possible, you need to use the shortest distance and the longest time. So use the lower bound for the distance, but surprisingly use the upper bound for the time. Another way to think about it is you can think of this as a fraction. To make a fraction as small as possible, you choose the smallest possible numerator and the biggest possible denominator. And if you work that out on the calculator, you get 7.00175 ... and so on meters per second. So that's the lower bound for Bob's average speed. Let's do the upper bound now. So to work that out, you just do the opposite. You choose the biggest distance, the longest distance, 100.05, divided by the quickest time, 14.265. So in other words, use the upper bound for the distance, but the lower bound for the time. And if you do that on the calculator, you get 7.01366 and so on meters per second. So those are the bounds. That's the lower bound, that's the upper bound, and Bob's average speed is somewhere in between, somewhere in that range. Now with these sorts of questions, there's often a follow-up question, like the one down here. So I'll just read it out. It says, write down Bob's average speed to a suitable degree of accuracy. So let's try 2 decimal places. So looking at the bounds, let's round the lower bound and the upper bound to 2 decimal places and see if they agree. So the lower bound, what's that to 2 decimal places? And the upper bound, what's that to 2 decimal places? Well, the lower bound rounds to 7.00 to 2 decimal places. The upper bound to 2 decimal places, what does that round to? Well, it rounds to 7.01. So they're not the same, they don't agree. So we don't actually know what Bob's average speed is to 2 decimal places, because some numbers in this range round to 7.00, some numbers in this range round to 7.01. So Bob's average speed could round to either of those, we don't know. What about 1 decimal place? Let's see if they agree to 1 decimal place, the lower bound and the upper bound. Lower bound, upper bound, let's round them to 1 decimal place. So what do they round to? Well, the lower bound rounds to 7.0, 7.0, and the upper bound also rounds to 7.0. So they agree. They're the same. So since Bob's average speed is somewhere in that range, it must also round to 7.0 to 1 decimal place. So we can be certain of his average speed to 1 decimal place, but we can't be any more certain than that. So the answer to the question is, Bob's average speed is 7.0 meters per second to 1 decimal place. That's the maximum number of digits we can be certain of. We can't be any more certain than that. Right, so this is the last question of the lesson. It's very different to the other two. So I'll just read it out. It says that some desks are each 1.2 meters wide to 1 decimal place. A room is 5.0 meters wide, also measured to 1 decimal place. And the question is, will 4 of these desks definitely fit side by side in the room? So you've got 4 desks side by side, you've got a room, and the question is asking, will the desks fit? Will the desks definitely fit is the question. So it's really asking, is it a certainty, or is there a possibility that the desks might not fit? Because these are rounded values, they're not exact values. So what do you think? Do you think the desks will definitely fit, given that information? Well, if you take those numbers as they are, if each desk was exactly 1.2 metres wide, and if the room was exactly 5.0 metres wide, then the desks would fit, because 4 desks, each being 1.2 metres wide, would be 4.8 metres altogether, which is less than 5.0, so they fit in that situation. But you've got to remember these are rounded values, so there's a range of possible widths for the desks, and there's a range of possible widths for the room as well. If you want to be certain that the desks are going to fit, then you've really got to consider the worst case scenario. You've got to imagine that the desks are as wide as possible and that the room is as small as possible. So it's all about bounds, really. So let's find the upper and lower bound for the width of the desks, and let's find the upper and lower bound for the width of the room. So starting with the desks, I won't do a number line this time, I'll just write it down. So if it's 1.2 to 1 decimal place, that means the lower bound is 1.15 and the upper bound is 1.25. And for the room, if it's 5.0 to 1 decimal place, what are the bounds going to be? Well, the lower bound is 4.95 and the upper bound is 5.05. And we're going to consider the worst case scenario. So we're going to imagine the desks are as big as possible and the room is as small as possible. So we're going to use 1.25 for the desks, 1.25, 1.25, 1.25, 1.25, and we're going to assume the room is as small as possible, which is 4.95 metres. So do the desks fit in this situation? Well, if you add these lengths up to get the total width of the 4 desks, you actually get 5 metres, which I'll write as 5.00, which is actually bigger than the width of the room in this situation. So in this situation, the desks don't fit. Which means the answer to the question, will the desks definitely fit, is no. They might fit, but there's a possibility that they won't fit, as this example shows. So that's it.